And we're back, and we're live. Josh, you missed the beginning of the Excel tutorial.
Yeah, you know what? I actually thought about that.
You could have watched the lesson on your own time.
Yeah.
Josh, in case you can tell, doesn't do his work.
I know. It's usually guesses. It's all. Anywho. So yeah, time is flying by. I will say, obviously, for those of you in the chat, please make sure you leave a comment. That would have to be absolutely wonderful. Yeah, I want to say more stuff about observations in general. Because like the observation. Oh, that's the story I wanted to tell you. Okay. I got observed by a former principal. Not the current principal, but a former principal, and several years ago. And in the observation report, at the end of each category, there was like a bunch of statements and comments, like a paragraph and stuff like that. And then at one point in the paragraph, the paragraph didn't say my name; it said another teacher's name. But it said another teacher's name of a teacher who left the school like 5 years prior. And then it occurred to me that the principal who was observing me was literally just cutting and pasting and changing the last name of the teacher. Like, I'm sorry, if you're going to observe me, the purpose of someone observing my classroom is to provide constructive criticism for me to improve myself in what I do. Maybe. But I'm saying about like the principal, though. I'm not talking Panula. Panula did a better job than this principal. Trust me. Much better job. But I'm just saying, like, so I had to, it was an official observation. So I had to go down to that principal's office and say, I'm sorry, there's a typo in my observation, because this observation is going to be, what are you doing on my chat right here? There. But anyway, there's like 16 billion.
Around. You have to take into account the fact that some people don't have two eyeballs.
Yeah, but how many people would that be?
Probably a lot.
Anyway, but I'm just saying, I had to go down to this principal and just be like, you're going to have to change this name on my observation, basically calling the dude out for cutting and pasting. You know, man. Anyway, back to this. I'm going to send you all something because we're going to wrap up affine ciphers, get a little practice review in right here. I have, actually, no, I've already sent it to you. Yeah, I've already sent it to you. For those of you on your computers right now, it'd be absolutely fantastic if you can open up this PDF that I sent into the stream the other day, because we are going to, with a combination of Excel and a little bit of know-how, we are going to decrypt number 5 on this thing. So let me open up Lumen PDF. Get this thing open right here, because I'm going to need to cut and paste this. Actually, no, I won't have to cut and paste this. I just need to put this into Excel, really. But the first thing that we have to do before we do that is we have to figure out, okay, can we determine any of these letters? Let me cut this into a Word document and make it a bit larger so we can kind of make some educated guesses. So let's see, make that like 30. Perfect. Okay. So here's what we got. This is number 5 on that PDF that I posted the other day. Now, we would love to use Excel to decrypt everything on here. But the first thing that we have to do is make some determination as to, okay, can we figure out the word the, or the word and, or the word a, or I, or something along those lines? Josh?
Yeah.
Who? G. Oh, there it is. GF does definitely show up twice. Absolutely, it does. And it could be anything. Yeah. What do you think?
FH are just like the other in a bunch of words.
Oh, that's right. Got an FH, 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 FH. It could be TH. That could be the word the. T-H-E-R-E. It could be. It could be. Let's work with that assumption because this is what you would have to go through. The word the. Question? Oh, okay. Guys in my chat room. You had your hand up. Okay. So if we assume that this is the word the, then we have to take action on this. So what I'm going to ask you to do, and I'm going to have you kind of go through this on your own a little bit because I want to see what you can do with it. I would like for those notebooks to be out and open.
So far away.
I know. So at some point, you will be using Excel to get this thing done. Hopefully, Josh, I'll be able to give you a small crash course as to what you missed. Okay? But let's see what we can do with our notes. I'm going to go back and forth between this and my notes right here. Maybe I can make this a bit larger. Hold on. I made it 30. Let me make it 40. Nope, too big. Hold on, how about this? Hold on. And perfect. I got no, not exactly. There it is. I got it all on the screen in one shot. Sweet. Back to this. Today is the 14th. Yeah, it's the 14th. And this is Affine Excel.
Or 3.
Sure. Quick note. Next week is the last normal week of the year.
Yes. Let's go.
Next week is the last normal week of the year because the following week, it's a 3-day week. The week after that is a 4-day week.
Thank you, seniors.
And the week after that is senior exams.
No.
So, okay.
Oh,
He's just looking for a high five. He's like, guys, somebody. Okay. So we think FHO could be the word the, and that's probably a good option. Frequency analysis, just looking how this thing goes, it could be the word the. We know that in affine ciphers that a letter could be ciphered to itself. That is entirely possible. So we think that the word the went to FHO. And based on that, we can begin the challenge of this decipherment. We're trying to see if we are correct in what we're thinking. So I am going to take, I know that T is what, the number 19? I know that H, I think, is 7, right? Hold on. A, B, C, D, E, F, G, H. Yeah, it's 7. And then B, C, D, E, that's 4. And then F must be 5. And then H is 7. And then O is 1 after N, 14. Okay. This is what our assumption is. Now, if we're wrong, we have to go back and try to figure out what this word is, or pick a different word and try to figure it out. This is purely right at the moment, guess and check. That's all we're doing kind of right now. Not exactly guess and check, but a little bit. The whole relationship should be 19K plus N equals 5. 7K plus N equals 7. And 4K plus N equals 14. Now, it's very easy to think at this moment that K is 1. You might think that K is 1. I don't know why. I mean, if you think, oh, well, if this is 0, no, it's not going to be that simple with K being 1. But we can take 2 of these equations and we can subtract them. Any suggestions?
-1 and 2.
Okay.
Good guess. Might be right.
Doesn't matter.
Doesn't matter.
It doesn't matter. You could take 1 and 2. You could take 2 and 3. You could take 1 and 3. It doesn't matter which 2 you take, but we're going to have to subtract them. So let's take, I'll take the first one you said. Let's take 1 and 2. Actually, hold on. I don't think I want to take 1 and 2. Here's the reason. Here's the reason. If I subtracted 1 and 2, I would have, what, a 12K? And then ultimately, we would have to then the other side, we'd have, what, a -2? We would then have to mod 26 the -2 until we got a multiple of 12. It may be much easier if we did the second and third equation. Because then, huh? Say again? -2 plus 26 would be 24. Oh, yeah, it would have to do it once. Oh, snap. He just logicked me. He just logicked me. Fine, I'll do it that way. I was just trying to make it easier for the long run, but you know what? That totally works. Ooh. Okay. 12K equals -2. But of course, we know that -2 is mod 26. So we'll add 26 to that. And we'll get what, 24? Huh. Now this, we're getting a little dicey here. Do you know why we're getting a little dicey here? K can't be 2. It's even. K can't be 2. That's interesting. Well, let me double check something real quick. My numbers here are correct for T, H, and E, right? And then F and H and O. Yeah, those are correct. And then those are the equations that we would set up. 19 minus 7 is indeed 12, right? I'm concerned that no one is answering. It's 12. And then 5 minus 7 is indeed -2. But then we would have to mod 26 it to get 24. But we know that the K value cannot be even. Hey, why is this girl standing outside my door? No. Yeah, what is she doing? Josh, go be weird.
When she's waiting for Miss South, she's like into school. Like student government and stuff.
Okay, Josh has done his weirdness.
I have no clue what that is.
Okay, good. But my point being, though, the K value cannot be 2 because the K value cannot be even. It cannot share anything with that mod 26. It can't have a factor of 26. Oh. Let me leave this be. Let me try the other one that we talked about. See if we can't get a better answer because perhaps it's not THO. Perhaps it's not THE. I'm sorry. Maybe it's not the word the. I got the right letters here. FHO. Yeah. Let's try Josh's idea of subtracting 2 and 3 right here. If we subtracted 2 and 3, we'd get 3x equals -7. Let me mod 26, that -7. -7 plus 26 plus 26, I get 45. Oh, but now it works. Now I get K equal 15. Ooh. Just to be safe, I want to check 1 and 3. I want to check 1 and 3. Because either there was a mistake with 1 and 2, but let's check 1 and 3. If I were to check 1 and 3, 1 and 3, if I subtracted them, I would get 15K equals -9. -9, I would have to mod 26 it by going plus 26 plus 26, plus 26, plus 26. Can I divide that? Nope. Plus 26, plus 26, plus 26, plus 26, plus 26. Yeah. 15k would then equal 225, and k is equal to 15. We got 15 again. Why did 1 and 3 do that?
We gotta do a full.
Do the math, 19 minus 7.
Okay. And we got -2, and then we took that -2 and we mod 26 to get 24. And then clearly dividing gets 2, but then the other two both produce the same number. That is concerning. Let's see what happens. Let's give it a shot. Let's give it a shot with k equals 15. Let's give it a shot just to see what happens. We still have to figure out n. We still have to figure out n. Let's give it a shot with k equals 15, and then we'll hit up Excel and see if it works. Because if it's wrong, then we can just change one little thing and then redo the formulas super quick. Oh, Josh.
I just got here.
So if we're going to figure out n, then it'd be 4 times 15 plus n equals 14. 4 times 15 is 60. N equals, I have to subtract 60, negative 46, and then mod 26 that thing. I would get 6. So the ordered pair that we're looking for is 15, 6. Let me double check to make sure that works in the other formulas, because I'm concerned about that first calculation. I'm very concerned about that first calculation. Unless, is t really 19? I really hope it's 19. 19 times 15 is to that, 5 to the 285 is that, plus 26. Yeah, 6. We got 6. Okay. To Excel! Okay. So for the sake of argument, I'm going to get you guys started, and then I'm going to let you finish the thing on your own. I'm going to get you started, and then you're going to get finished on your own to decipher this thing out. And while you're finishing it on your own, then I'm going to show Josh some of the finer points. So to get you started, first, I'm going to have my, this is my plain alphabet, which I'm going to type in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Look what happened when I typed in P. Fixed it. I'm going to centerize this just because I want to. There we go. And then plain number 0, 1, 2. Remember, you don't have to type in all the numbers. Highlight the first couple, double click, it'll fill in the rest. It's kind of nice. Then I need to put in my ciphertext. Now, this is where you guys got to do a little bit of maneuvering right here. You're going to have to type in this ciphertext into the column. So I can leave this up on the board for you, but obviously you also have the PDF. And then I can walk Josh through some of these things. Let's see. There you go. Did I get the whole text there? Sweet. So the way that you're going to do it, and you can leave spaces if you want, but I'm not going to. But I'm going to type in FHOBOWQTIY. In fact, I'm just going to go through the whole thing. EISSWTS. So the faster that you can type this in, the better. But obviously, double check to make sure that you're not making any major mistakes. Because if you do, you're going to have to go back and retype all of this. remember, even if we're wrong, all of the stuff that I'm currently typing in, we're still going to be able to use. Nice. I miss a letter? Does it count the semicolon? Oh, yeah, you're right. It does count it as a character, but obviously we're going to keep it as a semicolon, right? And then I think it counted the comma as well. Yeah, it did. That's so weird. Does it count the period? Oh, it totally does. That's so weird. So then subtract those 3. Yep, 121. Perfect. I got them. So I got my ciphertext. Okay. I'm going to see what you guys can do with this now. Take some time using 15,6 as your ordered pair. You're going to have to decipher this with 15,6. Just for the sake of argument, if you have the ability right now to bring up the mod 26 table, if you have the ability to bring up the mod 26 table, please do so. Because I got to know what the multiplicative inverse of 15 is. And again, for those of you in the chat, this PDF, number 5, is in the stream, in case you can't see it because of the glare. There it is. I just posted the link to that thing, so you can take a look at that. Anybody get the mod 26 table? Somebody beat me to it. I got it. It's 7. I beat you to it. Okay. Okay. So while you guys are doing that, I'm just going to give him a brief rundown as to what we did the other day. So Excel is one of those things that a lot of people think they understand, but they really don't. They don't know what it can do. You have little to no idea as to what this thing can do. For example, if I were to just open up another quick Excel spreadsheet right here. Here we go. Check this out. 1 plus 3. What do you think is going to happen? No. It won't. Unless you type in equals first. By hitting that equal sign, you open up Excel to do formulas. So now when I do 1 plus 3 here, it automatically calculates it to become a 4. But if you look at the top of the screen right here where my mouse is, it still has that original formula. So for example, if I were to type in, 11, 34, 65, 79, I could do equals, and now I've opened up formulas. But I could do average. Now, in order to utilize this average function, whenever you type in the function, you actually have to open up a parenthesis, like that. And then it says, well, type in the numbers. Okay, I could do 11, 34, 65. Or click and drag, and it figures out the average. It's really nice. It has like thousands and thousands of functions. Like this one does the sum. Insane. Hold on. Standard. There it is. I wanted standard deviation. Yeah, that'll do it. Standard deviation. Boom. Ah. mess up a formula. Whatever, I'll do that another time. Anyway, the other cool thing is this. If I were to, come on, delete that. Actually, no, let me undo that. Undo. Here we go, check this out. Let me take away the 11. It changes the sum and the average. It just all updates it automatically. But now check this out, ready? Equals, give me a 3-digit number.
123.
There's a mod function where you can type in the number and then the type of mod you want to do. And it automatically does it for you. Now, what's really nice about that, well, I'll show you that in a minute. But first, let me cut and paste this little thing right here. Right-click, copy, right-click, paste. I just wanted to paste that. Plain text, ciphertext. I did this the other day with the word Barnegat. Check this out. Come on, you. So if you were to encipher the word Barnegat, you would first need to modify it by changing it to its numbers. B would be equal to 1. A would be equal to 0. But if it's a really long text like the one that they're doing right now, it takes a while. So instead, equals lookup. What lookup does, parentheses, C1, that's the B in Barnegat, is where in the C1 cell. It's going to look up the B, but you have to tell it where to look. Well, I want it to look in column A. So I'm going to go up here to column A, click it, and then all of a sudden A to A shows up in where they're looking it up, in red. Then I hit comma one more time. And now I'm saying basically, okay, look up the B in column A, but return the number in column B. Look at that formula at the top. Now watch me click and drag this sucker.
Yo.
And it does it automatically, which is super nice. By the way, see what I just did right there? That's a nice little feature. If you highlight everything in the top left corner and then double click between two columns, it automatically sizes them out for you. But now we can take, let's see, I'll move these down a little bit. There we go. We can take these numbers and modify them. Like we can do a Caesar shift, right? Give me a number, Josh. Number. 7 plus 7. We're going to see, oh, hold on. Equals plus 7. There we go. Formulas. I'm going to do plus 7 to all of those. Ready? Equals this plus 7. Right, you know what? Give me a number greater than 7. Sure. Let's do 8. Equals this plus 8. Double click. I got to undo that. Undo. I'll just bring it down to here. So a Caesar shift, all up 8. Uh-oh. See the number at the bottom? That's outside my range. So here's what we're going to do. Instead of plus 8, I'm going to do this. Equals mod, parentheses, this number plus 8, comma, 26, close parentheses. And now when I do this, it won't say 27 at the bottom because it modded it by 26. It shifted the number up 8 and modded it by 26. But then I'm going to convert it back to cipher, text, that is, equals, lookup, parentheses, E2, comma. Now it's going to take that number. It's going to look it up in the number column, comma, and it's going to return the letter. So now Barnegat becomes that ciphertext. It's really nice. The other flip side of that is now we can take ciphertext and convert it back, which is what I'm about to do with everyone else right now. So I wanted them to have an opportunity to try that from the other day, and now we're going to do this thing together. Well, not exactly.
Now you know everything ever.
So here's our ciphertext. First thing I got to do is I got to convert this ciphertext into numerical values. Equals, look up, parentheses, C2, because that's the first number in the cipher, or first letter, comma, the alphabet column, comma, the number column. And it will convert that to a number. Double click, it'll convert all of them to a number. It's really nice. All the way down here, it converts everything. You don't have to worry about it. Now we know that it was 15,6, or we're hoping it was 15,6. We'll see if this works. It would have done f of x equals 15x plus 6. We would have had to subtract 6 from that number. And we would have to divide by 15. But dividing by 15 is not in our best interest. So, which is why I had you guys look up the mod 26 table, because instead of dividing by 15, we are going to multiply by 7. So this really should be 7 times f of x minus 6. That's the calculation that's going to take place. So I'm going to meander over here. I'm going to do equals, let's see, 7 times parentheses, this number, minus 6, close parentheses. That should do it. Oh, crap. What did I forget to do? Get to mod 26. Watch this. Now, Josh, this is the cool thing. If you mess up a formula, check this out. Double click on that cell. And now you can edit it by putting in the mod parentheses. Go to the end, comma, 26. Close parentheses. And it'll fix it. Click, double click. This is our, or these are our plain numbers now. These were our cipher numbers. Now these are our plain numbers. Let's convert those plain numbers back into plain text.
Marky, can you show me the mod formula?
This one right here.
Yeah.
I don't know if, oh, here we go. It'll let me do that, yeah. Because remember, I had to subtract 6 and divide by 15, but we're not dividing by 15. We are multiplying by 7, because 7 is the multiplicative inverse of 15.
Thank you.
Then we're going to convert this back with a little lookup. Lookup, parentheses, this 19 in the plain number column, and return the letter in the plain alphabet. Let's hope this works. We did get a T. Remember we said the first word should have been like the or there? Double click. This is what Excel allows us to do, Josh. It allows us to decipher an entire paragraph of work instead of having to go letter at a time. It's really nice. So there is now, I'm gonna have to scroll a bit. Turn this around. There is now less what? Flogging? There is now less, I think this says flogging. You know what flogging is? It's not good. There is less flogging in our great Scooths. Flogging, we'll look it up, but I know what it is, but it's, yeah. There is now flogging in our great, I think this was supposed to say schools, but I think it's missing a letter there. Yeah, it should be an L there, right? Let me double check the ciphertext. Maybe I missed a letter. Or Liston done screwed up again. Yeah. So let's see. FQKHII. FQ. Where is it? FQKHII. Yeah. There's now less flogging in our great. Yeah. He messed up a letter. Anyway, in our great schools, then for what? Then for Merle? Then for Merle? Then for... Oh, then for... Dude. For Merle. For Merle, like formerly. Yeah. Then formally, but the... Oh, no, but then less is learned there. Hold on, there's more to it, but I want to write that down. But then less is learned there. I wonder what happened with that first calculation that we did. But then less is learned there. So then what? So then one. So then one, the boy. We'll have to look this up. There's the guy's name. There's the quote for that guy. We'll have to look it up, see how close we got. So then the boys get at one end. What? So then the boys get at one end. They... We'll have to look this guy up. What's this guy's name? I think it was like Samuel Johnson or some junk like that. Oh, it wasn't. So then they lose at the other. Somebody Google flogging. I'll do it as well, but I want you to have the shock first. Let's see. Here we go. Flogging. A punishment in which the victim is hit repeatedly with a whip or stick.
Yes. So no more flogging in the schools.
Here's a device that they would use for flogging.
Ah, nice flog.
Remember, you ever hear of the cat of nine tails?
Nope.
It's basically like a whip with like multiple things, but at the very end of each whip is like pieces of like metal that when it hits you, it gets stuck in your back. Yeah, it's pretty messed up. Here's a cartoon image. That,
Based on true then.
yeah, they actually did this back in the day. Right there, there's a guy getting flogged. You've probably seen that in like random movies and stuff like that. Let me see. This was Samuel Johnson. Samuel Johnson quote on flogging. There is now less flogging in our great schools than formerly, but then less is learned there, so that what the boys at one end, so that what the boys get at one end, they lose at the other. That's true. But we did have the correct numbers. See, the thing is, when it comes to decrypting things, sometimes, and I'm not going to blame this on listening because I've actually seen it happen, sometimes there are certain flaws that are purposefully left in order to kind of mess people up, but clearly it didn't mess us up enough to get this answer. The thing that I'm confused about more than anything, not so much as the translation, but what I'm confused about is how come when we did equations 1 and 2, it didn't work?
The Mandela effect.
That can't be your answer for everything.
But it worked. You never know.
That's true. That's very true. I don't know. Some of those Mandela things, I'm like, no, I knew what the correct one was the entire time. And then like a couple of times they got me and I'm like, oh, snap.
You second guess yourself.
Yeah. You know, it really messed me up though, because I grew up watching the movie. I grew up watching E.T. And what's the thing that E.T. is famous for saying? Phone home. He doesn't say that. He doesn't say that in the movie. Hold on. We're looking it up now.
Someone had this thought, they were like, what if you died? And then they just got on the VR headset and say, how was it?
What was it? Yo, what?
Oh my god.
Hold on. We're looking it up now.
I am not. This is the most ridiculous thing I've ever seen.
Hold on.
Oh. Phone? He said phone? E.T. Home phone.
Home phone. Does that mess you up? He literally says it. Do it again. Hold on.
E.T. Home phone.
Your entire lives are a lie.
Now you're looking for insulation.
Something like that. Yeah. Home phone.
Josh is like, I still don't believe it.
Anyway. Yeah. So,
In my world, I'm not even horrible. In my
in your world, yeah.
We're in the fake world right now. We got
So,
the real world.
regardless of how this is done, what you're going to need to know for affine ciphers, because I am going to be throwing an assessment at you, probably later today. I'll post it on Google Classroom. The Excel portion is one thing. The Excel portion can come in handy. The Excel portion can obviously move things along a lot faster. But for the most part, you're going to have to know just how to decipher things by hand in this sense, where either maybe I give you the numbers to encipher, or I give you the numbers to decipher, or I tell you, hey, in this problem right here, like number 3, we did number 3 last time, I believe. Decrypt the following, assuming that the third to last word is the, where I tell you it's the, Or I give you something like this Samuel Johnson quote, and you have to then basically use your frequency analysis skills to figure out which one is the word the. So it all works out quite nicely with affine ciphers. But you guys are going to get that assessment, and then you're all going to high five afterwards. I assume as much. Anyway. Okay. Let's see. I need to. I didn't confirm with you the latest batch of Enigma problems, did I? I didn't confirm the answers, right? Let me confirm those for you. And then I want to talk about that just very briefly, at least one or two of them. First of all, number 7 was the enigmatic character studied maths at the University of Cambridge. And yes, it's maths. They call it maths out there. Yeah. Number 8, government communication headquarters. And number 9, as we talked about the other day, was indeed German naval codes. I know, this one's a bit easier. Yeah, but still. I gotcha. But regardless, the one that I actually did want to talk about of these codes was the Vigenere square. Because that one was probably the most tedious of them all. So let me go back here. Let me go up to the latest assignment here for the Vigenere square. Open that up in Lumen PDF. I like it. It is. For some reason, even though like I logged in like multiple times, it's still making me do it. Here we go. So with this one right here, they wanted you to decode this this cipher with the Vigenere square using the word chocolate. And the way that the word chocolate would work out is that above each letter, chocolat, it would keep repeating. Chocolat, chocolate, chocolate, chocolate. There we go. So the word chocolate being the key word would repeat over each of these letters. And then we would end up using the C column, the H column, row, the O row. We already did C, we already did O. We're going to do the L row. We're going to do the A row. Oh, the A row, which means if it's an A row, that means that that letter was never enciphered. And then the T row, and then the E row. And then it repeats. These are the 7 rows that we're going to be using for the Vigenere square, which is nice. So if we're in the C row, the I originally was a G. What was the answer to this one, by the way? There we go. And then in the H row, the V was originally an O. You can see up there. In the O row, the J was originally a V. And then it keeps going from there. I'll just do the word government. Then it goes back to the C row. G was E. The O row, F was R. In the L row, Y was N. In the A row, remember the A row is not actually enciphered at all. It just remains the same. It is an M. M is M. Govern. Yeah, I know it is. I'm just going through it. X is E row or E column, whatever. In the E row, R originally was an N. And in the C row, V was originally a T. It ends up spelling government. Vigenere squares are polyalphabetic, meaning that letters don't always get ciphered to be the same thing. In the word government, this N and this N ended up being different letters in the cipher. Govern, MENT, which is really nice about polyalphabetic ciphers. I mean, they are solvable as long as you have enough text to work with. As long as you have enough text to work with. Or you have an idea as to what some of those words could be. I mean, obviously, the Enigma machine was, to an extent, a polyalphabetic cipher. It was beyond 3 of them. It was like 3 of them with like whipped cream on top, you know, but at least 3, you're right. And that's what made it so incredibly difficult to crack. But if you just look at the basic Vigenere square cipher, there are certain clues that you can use to help yourself out. So what I'm going to do in a moment is I'm going to give each of you in this classroom a ciphertext that was enciphered using a Vigenere square. For those of you online, I do have the PDF that I am going to send you as well. So let me do that, and then I can send this PDF. Here we go. Now, while I'm trying to post this online for everybody, I'm going to ask that for those of you that already have it, take the time right now to see if you can find any repeating patterns. There are several that you can identify. And then I'm going to post this for everyone else.
In this,
Within that giant block of text. See if there's any repeated patterns that may end up being helpful.
I see a lot of double M's together. Some double W's.
Let me see here. Oh, that's right. Something a little bit more obvious than just double letters, though.
Triple letter.
Hey, how many words have a triple letter? Not
True. It's very true. Here we go. I finally found it for those of you that are online. I do apologize for the delay. Post. There it is. So I just posted, for those of you online, I just posted the PDF of this Vigenere cipher. It has been enciphered using a Vigenere square. The only thing that you don't know and that you don't have is a keyword.
There's a lot, but never mind.
Nothing yet?
There's Q and then
Logan, what's the answer to your riddle?
You gotta guess.
No, I don't like guessing.
Well, it sucks.
I don't like surprises. See, it's quite difficult to do a frequency analysis with a Vigenere square because of the fact that, well, like I said with the word government, the letter N did not cipher to the same letter. It ciphered to different letters. So under this word chocolate, it's like, oh, well, how many? They're using 7 different alphabets. And they're cycling through 7 different alphabets in the word chocolate.
So basically, the enigma is supercalifragilisticexpialidocious as a Vigenere square.
Possibly. And then at the end, they end up basically like taking all the letters and putting it in like a blender and shaking it up and stirring it around and then putting it back out, and somehow it makes sense. The Enigma machine is quite possibly one of the most like advanced pre-computer. I want to emphasize pre-computer, mind you, but one of the most advanced pre-computer scramblers of all time. You know,
Well, it's only until we tried it, by the way.
until it was cracked. Well, it was cracked by a computer. You know, so I want you to highlight some stuff, and let's see if I can't remember where this stuff was. There it is. Did you happen to notice these 5 letters matching these 5 letters? It's a flaw in the system.
That is pretty weird.
There's a flaw in the system because if there is a word that lines up with a keyword, then it would be enciphered in the same fashion. For example, let me go back to the word chocolate. Chocolat, right? That being the key word of the Vigenere square. If the word the was enciphered and the keyword chocolate was right on top of it, later on down the road, what if the word chocolate again occurred exactly where the word the was? That's not us. If something like that were to happen, if a repetition like that were to happen, that would give us a small foothold into determining, okay, maybe the first step is figuring out how long the keyword is. Now, I just highlighted 5 letters to you. Now, obviously, with a computer could easily find the repetition a lot faster. But I will tell you, and this is my little challenge for you today during this class period. Oh, I left it. Where did I leave you? Oh, there it is. There are 3 other repetitions like the one that I just showed you, but they're separated. They are separated. They're not right next to each other, and they are 4 letters or more. They are 4 letters or more. Now, this is obviously a bit more of a challenge, but see if you can't find them. It took me a few minutes of just careful scanning before I could find all of them. In fact, I unintentionally left you a few clues on this paper. Yep. If anything, the government would make his breath worse. Political humor.
Yeah.
Political humor. He did multiple times. Do you guys see the clues I left for you on that page? Yeah, EFIQ. If you look at the little top paragraph, I think Josh is falling asleep. Everyone be quiet.
So you have to say when I looked at this stuff above it,
Yeah.
I saw the dots for the eyes, and I thought that they were pinpricks at first until I realized they were all eyes. I was like, ooh.
Oh no,
Keyword. I'm like, huh.
no. That would be interesting, but no. So EFIQ. There's one of them right here. And where does the other EFIQ that I found? There it is, EFIQ. Now I'm going to show you what you can do with this once we kind of find all of them. But there's two more pairs that you can find. You can. If you look at the bottom right side of the whole page, I accidentally cut off some of the letters you should be looking for. I actually didn't intend to have that on the page when I scanned the book. The book's a little bit smaller than an actual textbook page. But I believe ETRL is one of them. ETRL, I just highlighted it right there. WCXY. I think that one was WCXYM. Yep, there it is. Watch this. Ready? Watch very carefully. There's WCXYM. And over here is WCXYM. Kind of goes over like that. Didn't what? Oh, maybe she didn't read it. I don't know. But I got to find that other ETRL. Where is the other ETRL? I'm going to cheat a little bit and look at there it is. It's right in there. Ha 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 ha. Now here's the thing. In a Vigenere square, the only way that you're going to get clues like this, in a Vigenere square is if the text is long enough, like this one right here. And what that is going to tell us, what that is going to help us figure out is the length of the key word. Why would the length of the key word be helpful to us?
Because it show when the patterns repeat. You can figure that out. Sections.
Exactly. If you can figure out the length of the key word and then possibly rearrange this text, you could rearrange this text in such a way where it's like, okay, let's just say, I'm going to make this up. Let's say that the keyword was like 6 letters long. If it was 6 letters long and we lined up this ciphertext in like rows of 6, then every column would in essence be its own mono-alphabetic cipher. This is kind of like the code breaking that people went into, the type of like creative thought that people were able to use in terms of cracking these things. Because I got to tell you, for about 200-300 years, Vigenere squares were the pinnacle of making codes. I mean, clearly the Enigma was better, but how long did it take them to crack? Like a couple years of non-stop working.
That was because out of the term, it was kind of like Atlanta.
Yeah. Like in Bletchley Park, they had a hodgepodge of so many different types of people from different backgrounds. Why do you think he went into a crossword puzzle to find people, you know? Just because like it's a different type of skill set for people to be able to solve puzzles. It's amazing. I don't know. So I'm just going to take you through a couple of steps of cracking this Vigenere square, but I'm not going to actually finish it today. Keep that in mind. So if you would, let us return back to our notes. Let us return back to our notes so that I can show you something. There we go. Nope, wrong one. There we go. Now I'm going to leave those markings on the board temporarily because I need to go back to the Vigenere square in a moment. But this is a continuation. Where's my other paper? There it is. Here we go. Vigenere. Decipher. Whatever it's called. So we found 4 sets of letters. We found PSDLP. That's a 9. P. We found WCXYM. We found EFIQ. And we found ETRL. We found those 4 sets hidden within the Vigenere square. Now, how does that help us? First, I'm going to go back to the Vigenere square, and I am going to look up repeat spacing. Now, what do I mean by repeat spacing? You'll see in just a moment. Going back to here. Look at the PSDLP. How many letters did it take? Okay. Well, let me say the full question, and then you'll say the correct answer, okay? The PSDLP repeats, when you start that P in the first PSDLP, the pattern repeats after how many spaces? No, say what you said before. 5. It repeats after 5 letters. Because if you start at the P in the first PSDLP, it goes 1, 2, 3, 4, 5, and then it actually repeats from there. You could do the same thing with the WCXYM, where you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then it repeats. So let me show you what I wrote down for this so far. Chappelle. That one repeats at 5. That one repeats at 20. Let me go to the other 2. That's why I left the squares on the board, so I didn't have to look at them again. I'm going to have to figure out the other 2. The EFIQ. Now, hold on. Let me double check something real quick. How many letters are in each row? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 15, 18, 22. There's 22 letters in each row. So I'm going to go from the first EFIQ to the next EFIQ. 22, 44, 66, 88, 89, 90, 91, 92, 93, 94, 95. 95. It repeats after 95 spaces. No, I know, but right now what we're doing is we're actually confirming something about this information. And now let's go to the ETRL. The ETRL repeats, well, again, I'm going to count down by 22s. 22, 44, 66, 88. 88 and 22, what is that, 110? Yeah, 110. 11, 12, 13, 14, 15, 16, 17, 18, 19, 120. It repeats after 120 spaces. Now, obviously, I did this one on purpose. But these repeated codes, as Logan is saying, all have something in common. They all have something in common. Well, 20, let's look at the number 20. 20 is divisible by, well, I mean, 1 wouldn't do anything if it just happened every once. Then it would just be monoalphabetic, but that's clearly not the point here. It's divisible by 2, it's divisible by 4, it's divisible by 10. 95, well, 95 actually is only divisible by a couple of numbers, 19 and 5. Huh. And then 120 is divisible by a ton of stuff. But what is the greatest common divisor amongst all 4? 5. The GCF of all 4 numbers is 5, which means our key word is 5 letters long. Now, this is going to be a little bit of a process. My marker's dying on me. See if I can write better with this one and throw this one across the room. Almost made it.
We're close.
Almost only counts in horse grenades. Letters long. You ever hear of horse grenades?
No.
It's very messy. But it means that our keyword is 5 letters long. Now, we still don't know what our keyword is. But based on this analysis, knowing that the keyword is 5 letters long, we're not about to go guess 5-letter words now.
No, I think it wouldn't take that long. There's only like 8,996 of them.
Yeah, that would take a bit too long. But knowing that it's 5 letters long allows us to take a huge step forward. Now there is a crack in the armor. Now, we're not going to do this today. Because I actually do have to type out these letters for you. I would rather type them out myself rather than force everyone to kind of type them out individually because there's a lot of letters. But what I'm going to do is I'm going to help you type out all these letters so that we can do some rearranging of the letters in such a way where we can do a different type of frequency analysis. See, because there's something else that Excel can do for you besides all of this lookup and modular stuff. Did you know that Excel can also create histograms? Just saying. And if you can create histograms, then you can figure out a frequency analysis of letters. And you can determine what the most common letters are and line that up against the general English version of frequency analysis. It's going to be nice. But that is for next time, because like I said, I still have to type all of this stuff out. You just looking up jokes now?
No, I made
Okay.
Let's go.
Wow. Anyway. But yeah, that's it for me today. You guys have about 7 or 8 minutes left in the class period. So for those of you in the chat, I'm going to leave it open just for a tiny bit longer. I do see the virtual students that I need, the names that I need to see in order to do proper attendance. So I know the other ones are already in the classroom. But yeah, anyway. So if you haven't left a comment, please make sure that you do so. If you haven't guessed the answer to Logan's last riddle, make sure you do so because I'm about to shut this thing down. Oh, he did it.
No one guessed.
Nice. Well, yeah, I am going to be, like I said, I'm going to be posting that assessment on Fine Ciphers. And then next time we come in on Tuesday, we are going to be attacking this Vigenere square with my typed up version of this cipher.
Before you go through all the work of typing it, you should try scanning it.
I have scanned it into a PDF.
No, like scan it into like the letters. You can do that. Technology is amazing.
Which app would do that?
Probably your phone.
That's true. I know, but my phone, I just got to figure out the app. Anyway, I'm going to sign off on this thing. Click and click. There we go.